This is 8.2, the law of cosines. I just got done making the video for the law of sines. So make sure you know how to use the law of sines and when to use the law of sines. Now, to use the law of sines, as a reminder, you use it whenever there's a pair. So whenever you have, like, let's say angle A and side A. So if you happen to know both side A and angle A, then you use the law of sines. So when to use the law of cosines? Well, it's when you don't have a pair. So that's when you have to know how to use the law of sines. Now, the law of sines, almost everywhere I look, textbooks, websites, they almost always write 3 different formulas. And a lot of times students think they have to know 3 different formulas. Well, as long as you know the purpose of the law of sines, you don't really need to know all 3 formulas. Really, it's all based off of one formula. It's just adjusted. Now, I wrote this one, and I want you to notice the way that it is. The way I remember this is, you guys recognize that part right there, c squared equals a squared plus b squared. So, that's like the Pythagorean theorem, and then it's just minus 2ab cosine of c. So the way I remember this as well, the formula, besides the Pythagorean theorem and then minus 2ab. So notice I have ab, and that's what's here. And then notice the c is what corresponds to the last. So if you're trying to find side C, you're going to use angle C. Or if you know angle C, if you don't know angle C, but you know side C, then you could use this as well if you wanted to. But again, those correspond to one another. And so if you're wanting to, rewrite another formula, again, you could just put that as a squared, and then you would have c squared plus b squared minus 2cb cosine of angle A. So notice the same thing. I have cb and then cb. And then notice the angle side correspond. And you can also do b squared equals a squared plus c squared minus 2ac cosine of b. So again, make sure you know one formula, and the others are just, it's the same idea, and be able to do that. So again, don't concentrate on memorizing 3 formulas. Just know the pattern. So again, when do you use this? You use this, the law of cosines, when you don't have a pair. So let's look at an example. So notice here I have side, side, side. I know all 3 sides, but I don't know any of the angles. So I don't have any pair whatsoever. So what we're going to do is find one of the angles, and it does not make a difference which one. I typically go for the biggest angle. So I notice the biggest side is side B, and so I'm going to go ahead and find angle B. That's what I would probably do on this. So we're going to use that formula with b squared equals a squared plus c squared minus 2ac cosine of angle B. All right, so we're going to use that formula since we're trying to concentrate on B. And let's plug in the information that we do know. So we do know b squared, that's 19 squared. We know a squared, which is 8 squared, and then c squared would be 14 squared. And then minus 2 times the a times the c cosine of angle B. We don't know angle B. Now after this, it just becomes pure algebra, knowing when to solve something. So let's evaluate the number. So 19 squared is 361. 8 squared is 64. And 14 squared is 196. I'm going to go ahead and multiply. You don't have to multiply those yet, but I'm going to go ahead and multiply those. That's 224 cosine of. All right. So what I'm going to do to solve this, again, I'm going to combine these 2 together because they're just numbers. So 64 plus 196 260. Minus 260 from both sides. So here I'm going to get 101 equals negative 224 sine of B. And again, I'm trying to find for angle B, so I'm going to divide both sides by negative 224. So cosine of B equals negative 101 over 224. And I need to solve for angle B, so I'm going to use the inverse cosine of both sides, and that's going to give me angle B. Make sure you're in degree mode, and I'm going to do the inverse cosine of negative 101 divided by 224. I'm going to get 116 degrees. That's going to find my angle B. So 116.8. Now, the law of cosines does require a little bit more work, obviously, than the law of sine. So what do we need to do after that? Because we need to find at least one more angle, and then we can find the third angle by just subtracting everything from 180. So you have a couple options. What you could do the exact same thing using the law of cosines and finding one more angle. Or we just got done learning the law of sines, because now we do have a pair. We have a side B and angle B, so now we have a pair. And so I'm going to go ahead and do that. I'm going to use the law of sines. The law of sines, I'm going to set up angle. Let's do angle, the next biggest side. So is 14. So we're going to find angle C, or side C. Yeah, angle C. So I'm going to do sine of C over side C. And then I'm going to do the side that, the angle that I do know, the pair that I do know is this right here. So I'm going to do the sine of 116.8 divided by 19. And I do want you to notice I did put the angle up top because that's what I'm trying to find. So here, I'm going to multiply both sides by 14. So I have the sine of C equals, and I'm just going to plug all that into my calculator. So the sine of 116.8, by that by 14, and I'm going to divide that by 19. So I'm going to get that answer, 0.65. Now on my paper, I'm just going to round it, 658. And then I'm going to take the inverse sine of this, because I'm trying to find the angle. But remember, you never want to use a rounded decimal in the middle of a problem. So I'm going to, on my calculator, I still have the exact answer. So I'm going to do the inverse sine of the exact answer. Don't do the inverse sine of the rounded answer. So do the inverse sine of the exact answer. All right, and then I'm going to get 41.12 degrees. Let's stay consistent. Let's round to the nearest tenths place. So it's 41.1. So 41.1 degrees. And then all I need to do is take 180 minus 116.8 minus 41.1. And notice I got 22.1 degrees. So I solved all three angles, and I have all three sides. So everything's solved for, and that's using the law of cosines.